Hello. So today we are doing this Leetcode problem called threesome. So yeah, let's get started. So given an array, name of, let me see just if the stream is working fine. It does seem to be cool. Hang on, what is this? Present everyone. Okay. Okay, now it should be working. Okay, cool. So what we are doing today is threesome, which is given an array nums of n integers. We want to look for three elements, A, B, and C, such that their sum is 0. We want to find all unique triplets in the array that have this given sum. And we shouldn't have duplicate triplets. So how can this one be solved? So we have this example here, which give us -1, 0, 1. Their sum is 0, and also -1, -1, and 2. So it doesn't have to be contiguous. So we can, of course, just do the brute force solution where we go through the array first, and then another time, and then a third time to iterate over all possible three numbers and check if their sum is equal to 0. But that solution is often cubed, so we can do a better solution. So I think, so if you take just the array and sort it, then we can use some kind of two pointers to know when should so that if the sum is bigger than 0, we can just move one of them to get a smaller sum, and if it's less than 0, we can move another one to get a sum that is bigger than 0. So let's try that. So let's take our array and sort it first, and then we can go through the elements in the array. So we know we are looking for three numbers. So that means we don't need to look. So if we are looking for so if we are iterating on just the first element, then we need to have two elements after it to have a sum of three numbers. So we can just do -2 here because we need two elements at least. and then after that, let's have two pointers. Sorry. So let's have two pointers, left and right. Left is going to be just the element after A, so let's call it I+1. And let's take the right one as the, so what we are going to do is we are just going to do something like this, where we are going to put, so we would have, okay, let me make this a little bit better. So let's do a comment section here, yeah. And then we could, yeah, so once it's sorted, that would be -1, 1, 2, and then we would have -4 here. And so what we are going to do is we are going to put E here, and then left here. And then we are going to put right all the way here. And then what's going to happen is that -4 plus -1 plus 2, we'll find that this is, so it's like -5 plus 2, that's -3. So this is smaller than 0. So in order to find 0, we need to, we keep I fixed, and we need to move left, because if we move right, then we would have a smaller number, which means here we would have the negative values still dominate, and then we would have values still less than 0, so it doesn't make sense. But if we move the left side, then let's see if that gives us a result that we want. So if you move the left side, what will happen? Instead of -1 here, we still have -1, so that's still same thing. Let's move then to this. And then in that case, we would have, so we would have +1, right? Which would be -2. And so that basically we would get, we'll put L on right, which will use the number 2 times, which is not what we want. So we can just do while left less than L. So that when they are equal, we can exit the loop to go to the next I. And so here we said that we are going to put the right pointer to the far right of the array. And so with that, let's have, so we would have current sum would be equal to plus ins of left plus ins of right. And so now what happens is we are going to advance I, since we reached this condition that the left pointer is equal to the right pointer. And now the sums that we have are -1 plus, and the left pointer just moves over here. So now we have the sum, our sum is plus -1 plus 2, right? And this is 0. So we need that case to be handled. So what we did earlier is we checked if the current sum is less than 0. That means we need to advance the left pointer. And if it's bigger than 0, then we need to advance to to move the right pointer to the left. Now what happens if they are equal? Then we have a solution, so we add it to our result array. So let's have a result array here. And let's append the solution here like this. So that would mean doing res.append the values that we have. So notice here, one thing the solution said is that the set must not contain duplicate numbers. So what if we had an array like this? So what if we had an array like the same one, except, well, actually, let's just take this example because we already have it. So here, -1, -1. No, let's take another array because this one doesn't handle the case for us. So what if we have a case like this, where -1 here too? So in that case, what will happen is that we will have I here. So -1 plus -1 plus 2 is 0. But also -1 plus -1 plus 2 is 0. And we don't want to duplicate that solution. We don't want to have this solution 2 times. We want to just skip duplicates. So that means here, when we find a solution, let's see if there are duplicates and just skip them. And so the way we will skip them is by doing just a while loop. So while we are still in the, we still have the boundaries set correctly. And if the left pointer here is the same as the one next to it, so then we just keep advancing the left pointer. And we do the same thing for the right, just in case we had also two like this. So that would mean, so here it would be R and R -1. And we can just do that. And in order to not keep iterating on the same solution, we need to advance both the right and the left pointer. And at the end of this, we can return our result. Oh, yeah, equal. Okay, yeah, we didn't define n, so let's define it. Okay. So our solution has one duplicate, even after we did this. Why is that? Oh yeah, so this is actually not enough. So what we can do is also for I, because here we handled for the left and right pointers, but we didn't handle for I also, because we may have the duplicates for I would advance here from -1 to -1, and we will calculate the same triplet again. So we need to handle that here. So we need to say if nim sub I is equal to the previous one, then we need to skip that. And also we need to check that I is not, that we can have I -1, so something like this. Okay, cool. To make sure this is working, let's just test with an empty array. Cool. And let's test with something like this. Okay. This may be with a lot of duplicates. Okay, this seems good. Let's try it. Cool. Awesome. Okay. See you next time. Bye.